right, everyone, welcome to this amazing theater session on serverless Kubernetes with Azure Functions and Azure Kubernetes Service. So thanks so much for joining. This is going to be a really fun session. Just even before we start, by raise of hands, how many of you here have used Azure Functions before? Okay, a little, actually most. And then how many of you have used Kubernetes before? Okay, wow, a lot actually. Okay, so we're going to show how these worlds can combine and you can bring the benefits of serverless compute with Azure Kubernetes Service in a single spot. So I'm Jeff Holland. I'm a program manager on the Azure Functions team. Work closely with some of our Kubernetes tooling as well. And to start with, because we only have 20 minutes, let's just look a little bit about what serverless is. And at its core, serverless is the ability to let application developers, IT operations experts, whoever it is, just focus on solving their business problems. So it's able to say, hey, I'm going to focus on my code, whether that code is PowerShell or C# or Python. You focus on the layers that matter most, and you leave the rest up to others to figure out, hey, I don't want to have to worry about scale. I don't want to have to worry about patching. Now, oftentimes, serverless is coupled with these three attributes. Serverless is event-driven. Your compute's triggered and available on an event. When I add a customer, run this code. When someone hits this webhook endpoint, run this code. It's on demand and available when you need it and only when you need it. So if there's no events happening, something like a serverless Azure function is not running. And one of the nice appeals for Azure Functions and serverless in general is that you only pay for those resources when you need them. So using this as a jumping off point, we're going to show how you can get many of these aspects inside of Azure Kubernetes Service as well. We'll even talk some about why that might be an option that some people would consider. So it's an example of a customer who's using serverless today. I like this scenario from Johnson Controls. They have IoT connected devices. They were working with us a few months ago, around 20,000 IoT devices, each of them sending data up into the cloud using Azure IoT Hub and Azure Event Hubs. Well, every time a device has an event, a function would trigger, would run some code. Hey, this device is sending this data. It's asked us to make this change. And then it could then interact with systems downstream, whether that's firing other events with services like Azure Event Grid, integrating with databases like Cosmos DB, or communicating with mobile applications. So this is a fantastic scenario for serverless because IoT devices have events, they have signals that they're emitting. The code here is running and scaling, whether it's a single device or tens of thousands of devices. So behind the scenes, what's happening to make this work is that you start with just a simple Azure function, right? And Azure functions are not scary. They're very basic. This is an example of what a function might look like. In this case, this is a function written in C# that's triggering on a queue message. So I can define in my code, I said, hey, I want to listen to the queue called queue and run whatever code I tell you to, which I didn't include that in the slide. You'll also have your event source. This might be a timer event or a queue. And then you deploy that to a function in the cloud. And you'll notice this function right now is a little hard to see because it's been faded because in this case, there's no events that are triggering. So your function's actually scaled to 0. You're not paying at all for that function. We just have the code here ready to run, deployed to Azure, connected to that app. Now there's one more element in this piece that many folks aren't aware of. And that's that in the Azure Function Service, we have this thing called the Event-Driven Scale Controller. And it's something that we manage, we operate, and its task is pretty easy. All it does is it looks at the event source, and it asks a single question, and it says, how many events are being generated, right? Right now I'm scaled at 0. How many events are generated? For something like a queue, that means how many queue messages are sitting on the queue waiting to be processed. Maybe the answer is 0, and so we don't need to run any code. Maybe the answer is 1,000, so we need to run a lot of code. So the scale controller keeps looking at this, and then eventually, some messages, some events will start happening. And it's our event-driven scale controller that notices that, and it says, hey, there's an event ready to go. Let's run this code. Let's trigger the function. So the function wakes up, and it runs the code that you've defined, that you've published to the cloud. And if there's a lot of events that are coming in, the event-driven scale controller will say, hey, we need more compute here. We need more servers behind the curtain of serverless, and it can very rapidly add more and more instances of your function app for you until eventually your events are consumed, all of your code has run for each one of those events, and it can scale you back down. All of this happens seamlessly behind the scenes for you in Azure Functions, but this event-driven scale controller is important. You might have even seen some demos this week where you'll throw something like 1,000 HTTP requests at an Azure function, and within the span of 30 seconds, you have 20 servers behind the scenes that have been spun up to handle those events. Now, you can take this code, this Azure function code that I'm showing here, and if you want to, you can run a single command, this func init docker only, and our tooling will generate for you a Docker file. Now, if you've never used Docker before and you've never used a Docker file, you don't even really have to understand what's in this code. It gets auto-generated for you. But it's a nice way to say, hey, I want to take this code and I want to package it so it can run in a container. Now, you can take this containerized function and give it to the Azure Functions service in the premium plan, and we'll run that container. But the other reason I wanted to call this out is because without me changing any code and just running the single command, it really shows that you can run Azure Functions anywhere. Azure Functions, this ability to very simply say, I have an event and I want it to run, and I just write the minimal amount of code to do that, you can bring those benefits wherever you want to run them. It doesn't have to be in the Azure Functions service. You can run them on an IoT device. You can run them on premises in a server, or you can run them, obviously, as the title of this theater session would lead you to believe, you can run Azure Functions inside of Kubernetes. So now that we kind of have looked some at what a function is and how it behaves in our service, let's pause for a beat and talk about Kubernetes. So many of you here were already familiar with Kubernetes. I'm going to give a very basic overview of what Kubernetes is if you're not familiar with it. So think about that you have an application. You just have some code that you want to have run. It's a website, whatever. It could be anything. And if you want it to run at scale, you likely have a lot of machines that are going to power that application, right? If I'm running Walmart.com, I'm going to need a whole bunch of servers powering that website. So imagine I just have a closet full of 100 machines that I need running my website code so that it can run across those machines. Now, without Kubernetes, it can be very challenging to log in and manage all of those 100 servers, making sure that they're up to date, deploying the code to it, starting up the code, all of that work. So all Kubernetes is really doing is it's orchestrating that work for you. You can imagine here you have this closet full of servers, these nodes, servers or virtual machines, that are all working together. You've joined them together. You've said, hey, you are now a Kubernetes cluster. And the magic of Kubernetes is that it will take your application and it will deploy it and run it and scale it across all of your nodes for you automatically. And kind of the brains of Kubernetes is called the Kubernetes Master. One of the benefits of Azure Kubernetes Service is that the master is managed and paid for entirely from Azure. You don't even have to worry about it as a customer. Now, this is a great model. But one thing to note is that Kubernetes, it does this basic set of functionality, but it doesn't do everything. And one of the limitations with Kubernetes, especially when we think about these event-driven and serverless workloads, is that Kubernetes by default only knows how to scale your app across machines based on CPU and memory. Meaning that it looks at one of the containers running in your nodes, and it says, how much CPU is this thing eating, right? Does it need 80% CPU? Does it need 60% CPU? How much memory is it consuming? And based on that, it's reactively scaling. It's saying, okay, it looks like this needs a lot of CPU, so I'm going to add one more. And then I'm going to wait, and I'm going to see if 2 is enough. And I'll keep looking at the CPU, and if the CPU keeps going up, then I'll add one more. So it's not as smart as that event-driven scale controller that we showed you for functions. It has no idea what's causing the traffic. It just sees the effects of the traffic, and it tries to react based on that. So one of the things that we wanted to do with Azure Functions being able to run everywhere is we wanted to make sure that when Azure Functions run everywhere, that it can run in a way that feels native and natural and has the same benefits of the Azure Functions service, even if it's not running in the Azure Functions service. So what we have created and shipped and built in the open is this tool called KEDA. Now KEDA, Kubernetes Event-Driven Autoscaling, is an open source component that you can install onto any Kubernetes cluster. It could be Azure Kubernetes, it could be on Amazon or Google or on premises or on a Raspberry Pi. You can install KEDA anywhere, and you can think of KEDA like that event-driven scale controller for Azure Functions, now running and scaling your containers. So KEDA looks at your event source, and it sees, oh, hey, this container is listening to queue messages, or this container is listening to Kafka messages, and it's going to drive the scale proactively based on that. It feeds that data into the native Kubernetes system. It's a very non-invasive component. You can just pop it into any cluster. It's not going to disrupt anything existing or new. It allows you to have your container scaled to 0. If you have a container that's listening to an event and there's no events happening, KEDA will let it completely scale to 0, so it's not consuming any CPU on any of your nodes. It's entirely open source. We built it with Red Hat and a bunch of the community. We're onboarding it to the CNCF right now as an open source, open governance project. I mentioned you can install it onto any cluster, and it has a bunch of event sources. I only listed a few here: Azure Service Bus, Event Hubs, Kafka, RabbitMQ, AWS services, Google Cloud services, Red Hat services. There's a bunch here that now Kubernetes knows about these events, and it can now treat your containers like serverless containers, okay? So KEDA is an important thing to note. So when you combine this event-driven scale controller of KEDA with Azure Functions in Kubernetes, you have a very similar experience in how your containers run and scale, but now running entirely inside of Kubernetes, all right? So I'm going to pause here and I'm going to show you a quick demo so you can see what this looks like in action. So I have here in Visual Studio Code, this is our queue-triggered Azure function. Again, you'll notice I didn't have to write any code here on how to consume a queue message, how to connect the queue SDKs, all of that stuff. That's the benefit of Azure Functions here. I just said, I care about queue messages. I could say, I care about RabbitMQ messages. I could say, I care about Kafka messages, and it's going to do everything I need for me. I could now debug and run this all locally. I could even go ahead and say, you know what, I want this to run in the Azure Functions service. So publish this now and run serverlessly. I don't want to have to manage any infrastructure. But if I wanted to, if I had requirements where maybe I required strict networking requirements, or I wanted more control over the compute that I'm using, or maybe I want this to run on premises, I can choose to run this inside of Kubernetes. So I have already a Kubernetes cluster that I've deployed, and I've installed KEDA inside of that. So if I say, hey, get me the pods inside of Kubernetes, you can see I've installed KEDA. I've installed this event-driven scale controller, so it's now running and able to listen for new instances. Now to get my function into Kubernetes is super easy. I just use the Azure Functions tooling, and I run a single command, which is func Kubernetes deploy. And this is saying, take the function that I'm working on, package it up in a container. I'm going to name mine queue function. I can publish it to a registry, a public or a private container registry. I can even configure some things, like polling interval tells KEDA how frequently to check for events, how frequently to ask the question how many events are happening. Cooldown period tells it how frequently to scale down. So I have some control in terms of how many minimums and maximums. So without changing the function code, the same function that could run in the cloud, by running this command, it packages it up in a container, and now it is running inside of my Kubernetes cluster. One cool thing to note here, this is listening to a queue, but you'll notice it's at 0. And that's because there's nothing on this queue. So I've published the container to Kubernetes. I've told it that it cares about queue messages, but it's not actually consuming any compute yet. So let's go ahead and just drop a queue message on so you can see what that looks like. So I'm going to watch this. You'll see there's nothing running, no resources found. Let's go ahead and switch windows here. And I'm just going to drop a queue message that says, hello, KEDA. Okay? Now I'm going to click OK, and when I switch back to this screen, you'll notice right away, KEDA noticed, hey, an event happened. I need to run this container. It had Kubernetes wake up, spin up my Azure Function app that's all running in Kubernetes. My function has now consumed it, and then it scales back down to 0, just like an Azure Function in the cloud. And just to show this one more time, let me log in here really quick. And we're going to throw 5,000 messages on that queue. So I'm going to simulate what if a lot of messages happen. And what's nice here is that instead of Kubernetes just guessing about how much scale it needs, instead of it just looking at the CPU and looking at the memory and trying to figure out if there's a lot of events happening, it sees here, okay, I have some queue messages, but KEDA's also going to notice, oh, there's a lot of queue messages. I need some more horsepower here to handle this. So you'll see just in a matter of that sentence, it's already added 4 containers to start processing those messages, and I would imagine by the end of this current sentence, it'll probably be at about 8. There we go. There goes the other 4. So KEDA is helping it get this event-driven serverless scale running in any Kubernetes cluster for any container. These are Azure Functions containers, but if I wanted to, if I just had ASP.NET or Python or Go, and I chose not to use the Azure Functions runtime, that would work with KEDA too. The benefit of the Azure Functions runtime is that I can keep my code just this simple. I don't have to worry about wiring it up to the event source. So that's one aspect of serverless. That's event-driven scaling. Now let's talk about a different aspect of Kubernetes. So we already talked about this one, about how Kubernetes scales across nodes. Well, by default, that means when you spin up Kubernetes, you have to select how many servers do I want powering my cluster, right? In this graphic, I have 6. That means that I'm paying for 6 servers 24/7, even though I may or may not have functions that are actually running on them. So that doesn't feel super serverless. And so the feature here that helps out is serverless nodes or virtual nodes is a feature of Azure Kubernetes Service. So you can take a cluster inside of Azure Kubernetes Service, and you can enable what are called virtual nodes. And virtual nodes means that by default, you might only have 1 or 2 or 3 nodes that you're paying for. But if I got a massive amount of traffic, like what I was just showing in the last demo, it will continue to scale out onto serverless containers. Containers that are running on what's called the Azure Container Instances, which is a separate service. And it will spin them up on demand, run your container in them, and once the load has decreased, it will get rid of them. And you only pay for these virtual nodes when they're actually allocated to your cluster. So virtual nodes means that you can now start to get some of the serverless kind of on-demand compute as well with Azure Kubernetes Service. Because yeah, you'll have your base nodes that you know for like some steady traffic, but when that traffic comes in, when those events pile on, you can now start to scale out into serverless containers. So the combination now, it gets even better. So you've got your Azure Functions that you've stuck in a Docker container. You install KEDA in the cluster, and I made dotted lines here to say, you know what, I could run the same demo, and if I had the time, I would run the same demo. And I could say, do exactly what you just did, but when you spin up those containers, spin them up in virtual nodes. And I'm only going to pay for those virtual nodes when they're actually running. So this is really powerful, because now you have this on-demand compute, this event-driven nature, all within Kubernetes. So a few resources here as we start to wrap up. KEDA, as I mentioned, is open source, so I linked to it right here. The demo that I did of writing an Azure function, packaging it up in a container, running it in Kubernetes, there's a step-by-step tutorial to build exactly that. So if you've never played with this before, this second link takes you to that sample. There's even a section at the bottom which will have you do it using virtual nodes and serverless containers. So it's a fantastic one to try it out. If you have any questions and you don't find me here on the show floor, Twitter's probably the easiest way to reach out to myself or the team. And get involved. All of this exciting stuff around Kubernetes and containers and open source is all happening in the open. We want to work with the community. So KEDA, we have community stand-ups every Thursday. There's GitHubs on that. There's details on that GitHub repo. So we hope you get involved. We hope you see the value here of sometimes you might need to run functions in a different environment. You don't have to give up the benefits of the programming model to run it in something like Kubernetes on premises or the Azure Kubernetes service, you can still bring many of those benefits and run it elsewhere as well. So thank you all so much. That's time for me right now. But I appreciate you all coming. Let me know if you have any questions, and hope you enjoy the rest of your conference.